Hello, this is Roopa Prasad, Assistant Professor, Department of Computer Applications, MITS College. So, today we are going to discuss about digital signature. So first we go for the contents. So first we are going to discuss about what is digital signature. Then we go for the process of digital signature. Then we discuss some of the properties of digital signature and their requirements. Then we go for the approaches of digital signature. Actually we have the two approaches. One we call it as RSA approach and second one we call it as a DSA approach. Then we directly come to the algorithm, digital signature algorithm. Okay, so first coming to the topic digital signature. So this digital signature is a mathematical technique. So this digital signature is a mathematical technique, and what form we are using this digital signature means we are using this digital signature in order to validate the authenticity and integrity of a digital document. Okay, authenticity means verifying the identity, and integrity means that the document is not modified during the transfer or anything during the storage also. Okay, so this digital signature is a technique. This digital signature is a technique which is used to validate the authenticity, as well as the integrity of the digital document, or we can call it as a message or software, anything that is digitally present. Okay, for this digital thing, we are going to provide the authentication and also the integrity by using a mathematical technique called as a digital signature. Okay, and this digital signature is similar to handwritten signature, but it is in the digital ring. Okay, that's the definition of the digital signature. So what we said, the digital signature is a mathematical technique which is used to validate the authenticity and integrity of a digital document, message or software. And coming to the digital signature process, so this is a simple process. So see here, so here Bob is a sender and Alice is a receiver. That is, Bob is sending some document to Alice, and Alice has to verify the identity. It has to check the authenticity and also the integrity. For that purpose, Bob is going to use a technique that we call it as a digital signature. So this is a message that Bob wants to send. Okay, first this message will be sent to a hash function, cryptographic hash function. Most probably we are using the SHA-512. So by sending this message to the hash function produces the hash code. That is the output of this hash function. This hash code is given to the algorithm that we call it as a digital signature generation algorithm. And the digital signature generation algorithm is going to generate a value that we call it as a sign. Okay, to this sign the original message will be appended, and that will be sent to the receiver. Okay, and for this digital signature generation algorithm, we are going to use a Bob's private key. In order to prove the authenticity, we require the private key of Bob. Okay, that is a sender. Sender is using that is a main signature. Authenticity can be done by using the private key only. Okay, why? Because the private key is available with this person, with the sender only, and this message can be decrypted by using the public key of sender only. Okay, public key of Bob. It means what? The message has been given by Bob only. For authenticity, we are using this one. Okay, so that will be used for the digital signature generation algorithm, and it produces a sign that we call it as the digital signature. So this signature will be appended to the message, will be appended to the original message, and it will be sent to the receiver. That is a Alice. Okay, now this Alice is going to perform the verification algorithm. Okay, whoever is sending the document, he is going to use a generation algorithm, and this receiver is going to check the verification algorithm. He is using the verification algorithm. So what happens? What Alice is going to receive is the Alice is going to receive the message along with the sign. Okay, so what Alice is going to do means that she is going to give this message to the cryptographic hash function that has been used by the sender. So this cryptographic hash function generates a hash code. Okay, that hash code will be given as input to the verification algorithm. Along with this, we are giving the input sign is given as an input, and also the public key of the sender. That is a Bob's public key will be given as an input to the digital verification algorithm. And this digital verification algorithm is returns a signature valid or not valid. Okay, this is the overall digital signature process. Later we discuss in detail. Okay, so what is the digital signature process? Here Bob is going to sign a document and he is going to send Alice. So what is the thing he is going to sign the document means the message, whatever the message he want to send, that will be given to the cryptographic hash function. Generally we are going to use SHA. Okay, that produce a hash code, and this hash code along with his private key is given as input for the digital signature generation algorithm, and it is going to produce a sign. Okay, this sign will be appended to the original message and it will be sent to the receiver, what we call it as a alias. Now what the alias is going to get means the message along with the signs. Okay, so this message is given to the cryptographic hash function, and this cryptographic hash function produces hash code, and this hash code sign and also the box public key is given an input to the digital signature verification algorithm, and this digital signature verification algorithm will say whether the signature is valid or not. Okay, that is the process of digital signature. And coming to this one, properties. So we discuss some of the properties of digital signature. So what the message authentication is going to do means whatever the things we have discussed earlier, whatever the encryption techniques, hash functions, what they are going to do means it protects the two parties from the third party. Whatever the hash function we have discussed, that is a SHA function, and also the encryption process, everything is going to protect the two parties, that is sender and receiver, from the third party. Okay, so there is no technique which is going to protect against each other. Okay, so the two parties may have several disputes are there. Like for example, suppose John is sending a message to Mary. Okay, John is one person and is sending a message to Mary by using the private encryption or public encryption. Any encryption can be used in order to have the confidentiality, integrity, all those things. So he can use the private encryption or public encryption, and even though some disputes may arise, like what are the disputes means? So see him. John has sent a message to Mary. Now what Mary is going to do means Mary is going to forge a different message and claim that it has come from John. Okay, there is no proof that John has not sent this message. Okay, what it is going to do means Mary would simply have to create a message and append the authentication code using the key that John and Mary share. That is in the private key encryption. In private key encryption, what happens? John and Mary is going to share same key. Okay, whatever key is used by John, that is only used by Mary. So what the Mary is going to do means Mary is going to frame a different message and claim that it has come from John. Okay, and there is no other way in order to prove that it has not come from John. Okay, that can be done by the other party. Okay, or if they use the public key encryption, what can be done? What is can be done means John can deny sending the message because it is possible for Mary to forge a message. So there is no way to prove that John did in fact send the message. We cannot able to prove that John has sent the message or Mary has received the message. Okay, so these are some of the drawbacks that we are going to face in the communication, in the cryptographic communication. Okay, for that purpose, what we have to do means there should be some authentication. There should be some authentication is needed when there is no trust between the two parties, there is sender and the receiver. So that we call it as a digital signature. So this digital signature are having some properties. So what are these properties? So the digital signature must verify the author. That is important. Okay, we are going to give protection against each other. So this digital signature, this mechanism must verify the author and date and time of the signature. Not only the author, it has to verify the date and time. Date and time is also important. Why? Because replay attacks may be possible. In order to avoid those things, this digital signature must verify the author. Not only the author, it has to verify the date and time of the signature, and it also authenticate the contents at the time of signature. So it has to authenticate the content. It has to authenticate the message at the time of signature, and it must be verifiable by third party. Okay, if any dispute arises, it has to be solved by the third party. So it must be verifiable by the third party. Okay, for this purpose, the digital signature function also includes the authentication function, what we have seen in the process. Okay, in the digital signature process, we are using the hash function. So why the hash function is used means in order to provide the authentication, and so these are the properties. So these properties can be filled by following the requirements. So what are the requirements here? The signature must be a bit pattern. Okay, the signature must be a bit pattern that depends on the message being signed. Okay, so the signature has to be derived from the message only, and it should be in the form of bit pattern. That is the first requirement for digital signature. And another requirement is the signature must use some information only known to the sender. Okay, so the signature must also include information that is only known to sender. Why? Because in order to prevent both forgery and the denial. Forgery means the receiver is going to give another message and claim that it has been sent by sender. Okay, the sender can also deny. So, in order to avoid these two conditions, the signature must have some information only known to the sender. And another requirement is it is relatively easy to produce a digital signature. The process should be simple in order to produce a digital signature. And it is also relatively easy to recognize and verify the digital signature, because in case of disputes, the third party is going to recognize and verify, or the receiver has to verify. So this digital signature should be relatively easy to recognize and verify. And one more important requirement is it is computationally infeasible. It is computationally infeasible to forge a digital signature either by constructing a new message from an existing digital signature or by constructing a fraudulent digital signature for a given message. That is very important. For this purpose only, we are going to use the hash functions. Okay, hash function is a one-way function. Okay, so it makes it computationally infeasible to produce another digital signature for the existing document. And it must be practical to retain a copy of the digital signature in storage. So and there must be some provision in order to retain the copy of the digital signature. So a secure hash function embedded in the scheme provides a base for satisfying these requirements. All these requirements, whatever the requirements we have discussed, that can be satisfied by using a hash function. For that purpose only, in the digital signature process, we are including the hash functions. Okay. And there are two approaches for this digital signature. So digital signature can be fulfilled by using any one of the approach, and we are calling this as the two approaches. And what are the approaches? The first approach is called as the RSA approach, and the second approach is called as a DSA approach. Okay, there are two approaches to its digital signature. To form the digital signature, we can go for the RSA or we can go for the DSA. So in RSA approach, what happens? The message to be signed is input a hash function that produces a secure hash code of fixed length. Okay, the hash code is then encrypted by using the sender's private key to form the signature. Both the message and signature are then transmitted. That we call it as a RSA, Rivest-Shamir-Edelman approach. In this approach, what happens? The message will be given to the hash function that produces a hash code. Later, this hash code is encrypted by using the sender's private key, and then the message and signature are transmitted. That is the simple RSA approach, and this is RSA approach. See, in this diagram, we can show the RSA approach. So what happens? This is the sender side and this is the receiver side. So what the sender is going to do means the sender is going to send the message to a hash function so that it produces a hash code. This hash code is encrypted. In order to provide confidentiality and authentication, the hash code will be encrypted. The hash code will be encrypted by using the private key of sender. This mainly proves authentication. Okay, and what we call this one? We call it as a signature. The output is called it as a signature, and this signature is appended to the message. And it will be sent to the receiver. Okay, what the receiver is going to get? The receiver is going to get the message along with the signature. So what is a signature? Signature is a encrypted hash code. It is encrypted by using the private key of sender. So what happens? What the receiver is going to do means the receiver is going to decrypt this encrypted part. This part is encrypted. Okay, so it is going to decrypt by using the public key of A, public key of sender. Why? Because it is encrypted by using the private key of sender. It has to be decrypted by using the public key of sender. Okay, then we get the hash code. We get the hash code. Meanwhile, the message is sent to the hash function in order to produce a hash code. Okay, then the received hash code is compared with the calculated hash code. Compared with the calculated hash code. If it matches, then only the signature is valid. Then only the signature is valid. This we call it as an RSA approach. This we call it as an RSA approach. And there is another approach, what we call it as a DSA approach. That means in DSA approach, it is making use of a digital signature algorithm. Digital signature algorithm. Let me talk about the digital signature, then history of this digital signature. So this digital signature has been published by NIST. Under FIPS 186, and this makes use of a secure hash algorithm. It makes this DSA approach makes use of a secure hash algorithm, and this DSA was originally proposed in 1991. Later it has been revised in 1993. First it is proposed in 1991, later it has been revised in 1993. Okay, and after that it has a minor revisions are there in 1996, and in 2000 expanded version has been published, and in 2009 also it has been revised, in 2013 also it has been revised. Okay, and the latest version also incorporates digital signature algorithms based on RSA and on elliptic curve cryptography. By using these public key cryptographic algorithms, these digital signature, the latest version of the digital signature incorporates the main public key encryption algorithm, that is the RSA and also elliptic curve cryptography. Okay, then coming to the approach. So this, by using this diagram, we can explain this approach. So here the message will be given to the hash function. The message will be given to the this is the sender side and this is the receiver side. Sender is going to perform the signature algorithm and the receiver is going to use a verification algorithm. And here we are going to use the digital signature algorithm. In this we have the two algorithms are there. One is for the for generating the signature and one is used to verify. Okay, so the sender is going to use a signature algorithm, whereas the receiver is going to use a verification algorithm. So what happens? The message is given to the hash function. The message is given to the hash function, and what will the output? The output is the hash code. The output is a hash code. That hash code is given as input to the signature algorithm. Is given as input to the signature algorithm. In addition to hash code, we are going to make use of private key of sender. We are going to make use of private key of sender, and we are going to make use of a set of parameters known as global parameters. Global parameters, public global parameters, public global parameters. We will discuss how these can be derived. Okay, so this signature algorithm. For this signature algorithm, we have the inputs like hash code, which is generated from the when the message is given to hash function, it generates the hash code. That is one input. Another one is private key of sender, and another one is global public key elements. Along with this, we are going to use k constant. We are going to use a randomized constant called as k. Okay, that will be given as input for the signature algorithm, and the signature algorithm is going to generate two outputs. It is going to generate two outputs. One is called as S and one is called as R. S and R. Okay, that will be appended to the original message. That will be appended to the original message, and it will be sent to the receiver. And it will be sent to the receiver. Now, what the receiver is going to receive? The receiver is going to receive a message and two components. One is called as S and the one is called as R. Okay. So what happens? What the receiver is going to do means receiver is going to use a verification algorithm. Receiver is going to use a verification algorithm. For this verification algorithm, one of the input is the component S. Okay, and one of the input is public key of A because it is encrypted, because here we have used the private key of A. Obviously, we have to use the public key of A, and also the global public key elements, and also the hash code generated from the message. Okay, all these will be input to the message. All these will be input to the message. So it gives one output. It gives one output that will be compared with the component R, which has been received by the receiver, which has been sent by sender. That component that is called as R. Here the signature is going to give two components. One is called as S and one is called as R. Okay, and the output of this verification algorithm is compared with R component. If it equals only, the signature is valid. Okay, hope you understand. So this we call it as a DSA approach. So this DSA approach makes use of digital signature algorithm. In the digital signature algorithm, we have two algorithms are there. One we call it as a signature algorithm and second one we call it as a verification algorithm. Okay, signature algorithm is used by sender whereas the verification algorithm is used by the receiver. Okay, how the for this signature algorithm, what are the inputs? The hash code generated from the message and a randomized key called as a constant called as k, private key of A and global public key elements. It produces two components, one is called as S and one is called as R, that will be appended to the original message and it will be sent to the receiver. Okay, what the receiver is going to do means receiver is going to send the message to the hash function in order to generate the hash code that will be given as input to the verification algorithm. Along with this, the receiver is going to give yes and R to the verification algorithm and also the public key of A and global public key elements, and it is going to generate the output. That output is compared again as the R component which has been received. Okay, if it equals only, the signature is valid, or otherwise the signature is not valid. Okay, now come to this algorithm. So we discuss this algorithm. So digital signature algorithm. First we will see the global public key component. Global public key components. So there are three components are there. There are three global public key parameters are there. One we call it as a B. Okay, one we call it as a P. That is a prime number. So n bit prime number is n bit prime number, and another parameter is q, and finally we are calculating g. So there are three primary global public key components. One is called as P, prime number, and one is called as Q, which is the prime divisor of P minus 1, and one is called as G, which is calculated as H into P minus 1 by Q, is an exponent component mod P. Okay, so these are the three global public key components are there. And what is the restriction for this prime number is it should be in between. It should be in between 2L minus 1 and 2L. Okay, so L should be between 512 and 1024 bits. Okay, then this Q is a prime divisor of P minus 1, and whereas H can be calculated as, it should be in the form of H of P minus 1, H of P minus 1 divided by Q mod P, where H is an integer between 1 and P minus 1. And it should be, there is a restriction that G must be greater than 1. So these are the three global public key parameters, public key components, or we can call it as parameters. Now, by using this one, by using the public key, we have three parameters are the global public key elements, what we call it as P, Q and G. Okay, by using this one, the sender is going to calculate its private key and his public key. So X is a random number. It is a private key is chosen as X. So this X should be in between 0 and Q. This X should be in between 0 and Q. X should be chosen like that. It should be in between 0 and Q. And by using this one, by using this X, the sender is going to calculate the public key. So Y is a public key. Y equal to G power X mod P. Okay, then one pseudo random integer K will be chosen, and this K should be in between 0 and Q. 0 and Q. So the sender is going to calculate its private key, his public key, and also one pseudo random integer is chosen. Okay, so and we go for the digital signature algorithm. So this is the signing process. So the signature algorithm is going to generate the two components. One is called as R and one we call it as S. And how R we are getting means G power K mod P mod Q. By calculating this one, G power K mod P mod Q, we are getting the R. And how we are getting S means K inverse into hash code plus X into R mod Q. Then we get the S component. And the signature algorithm is going to generate the two components that we call it as R and S. Okay. So along with the message, these two components are sent to the receiver. At the receiver side, we are going to use a verification algorithm. So how the verification algorithm is performed means we have to calculate S dash is a received S component, M dash is a received message, R dash is a received R component. By making use of these one, we are going to calculate this one. The output of the verification algorithm will be G power U1 into Y power U2 mod P mod Q. How U1 is calculated means hash code of the received one into W mod Q, and how U2 is calculated means received R component into W mod Q. Okay, like that we are going to get the component called as V. Okay, and this V is compared with received R component. Received R component. If it matches only, the signature is valid. The signature is valid. That we call it as a DSC approach. So that can be seen by using this diagram. See, look at this diagram. So the message, okay, this is a signing process. So the message is given to the hash function. So it generates a hash code. And this hash code is given for this signing process. So what is S? How S is calculated means two components will be calculated. So how S is calculated? K inverse. K is the randomized integer. K inverse into whatever the output we got from the hash function, that plus X into R. X into R. What is X? X is a private key, and R is this one, what we have calculated by using the global public key elements. Global public key elements. R is calculated by using the global public key elements, and by using this we are calculating S component. So these two components are appended to the original message and it will be sent to the receiver. Okay, and what happens if the receiver side verification is done? So how the verification is going to done means the received message is given to the hash function. It produces hash code. By using this hash code and by using the public key and also Q and G, we are going to calculate U1, U2 and V. Okay, so and by using this received S component, we are calculating W. So all these will be given to this verification algorithm. And what is output? V is output. V is a final. V is the output. So this V is compared with our received R component. Received R component. If the signature is if it is equal compared. If it is equal only, if it matches only, the signature is valid. Otherwise, the signature is not valid. That we call it as a DSA approach. Okay, so digital signature can be done by using RSA approach, or we can go for the DSA approach. Okay, and this material is prepared by using these references. And if you have any queries, you can give your query into this form. Okay, hope you understand. Thank you.